Okay, question 10. We have our question here. It says a cyclist rode from town P and stopped at town T. The speed in kilometers per hour at which the cyclist rode is represented by this equation, right? So this is the equation to represent the speed in kilometers per hour. They say, note, speed is the rate of change in distance with respect to time. Then 10.1 says, calculate the maximum speed that the cyclist reached on this ride. The what? The maximum speed, right? Now, first, let's understand this. Our S in terms of T represents the distance. This is the original formula. Then our S prime T would have to represent the speed or the velocity. So, and then we have our S second derivative of T would have to represent the what? The acceleration. Now, if we are looking for the maximum speed reached, that means we have to look at where the acceleration would have to be equal to zero, meaning that the maximum speed is a constant speed. So this is a constant maximum speed. So a constant maximum speed would mean that my acceleration would have to be 0 meters per second square, meaning according to this, my second derivative would have to be 0, right? So in order to calculate the maximum speed, I would have to find the time at which there will be an acceleration of 0 meters per second square. So what do I do? Come over to this one and say I am given this speed equation. So the equation to represent the speed, but let me derive it further so that I have the equation to represent the what? The acceleration. So that's negative 6t and then plus 18. But then acceleration would have to be 0 for me to reach a maximum constant speed. So that's negative 6t and then plus 18. Transpose this one, that's 6t and then equal to 18. Divide by 6 both sides. Then t would have to be equal to what? 3 hours, right? But then I'm not done because all I'm trying to calculate is the maximum speed. So I just found the time whereby the cyclist will reach that maximum speed. So after 3 hours, the cyclist will come to a maximum speed. And at that point, it will be moving at a constant velocity, a constant speed, right? So, okay, now at this point, we are just going to say, let's take this 3 here and use it on this formula now, because we are trying to find the what? The maximum speed, right? When that acceleration is 0. So t is 3 here. That means I'm going to come there and put 3 wherever there is t. And then when I punch all of that into my calculator, I get 27 and then kilometers per hour. So that is the maximum speed that will be reached by the cyclist after some time, right? After 3 hours. Okay, then that's how you were supposed to calculate that. That's how you were supposed to calculate that. So making that equal to 0, it's a mark. And then having to find the value of t, it's a mark. And then having to find 27 kilometers per hour, it's a mark. So 3 marks like that. Okay, then calculate the distance between point P and town T, right? How do we then calculate this? Again, let's keep this here. So we still understand that ST is the distance. S prime T, first derivative is the speed, and the second derivative represents the acceleration. Now we are to calculate the distance between point P and town T. But then remember what we are being told. The cyclist rode from town P and stopped at town T, right? There are 2 points whereby the cyclist will be found to be stationary. Initially, when he's starting at town P, and then finally when he has now stopped at town T, right? So that means here we are trying to calculate. So with this equation here, we can calculate where our acceleration, where our speed will be equal to 0. Remember, speed equal to 0 meters per second means that this is at rest or has stopped, right? So this means it's at rest or stopped. Now, this question is a little bit unfair for those ones who are not doing physical sciences, right? I feel like such questions shouldn't be there because now, what about the ones that are actually doing accounting? right? So, but then a little bit of physics background actually helps you to answer these questions. Calculate the distance between town P and town T, right? So, okay, this is what we are going to do. First, we understand that if we can make our ST 0, it means that the speed is 0. And at that point, it means that the cyclist has stopped. So we're going to start by saying S prime T is equals to negative 3T squared plus 18T. Then we put 0 here. Negative 3T squared plus 18T, right? So we can take it over to the side. 3T squared minus 18T is equals to 0. Factor out 3T. It's a common factor between the two. And then we have T minus what? 6 is equals to 0. So we're going to end up with 3T is equals to 0, or T minus 6 is equals to 0. We would have to divide by 3 both sides here, and then T would still be equal to 0, or T would be equals to 6 hours. Now, obviously, the 0 represents that initially when he starts at town P, he would have been stationary before he starts cycling. And then 6 hours, that's when he reaches town T and stops there. So obviously, we have to continue with the T is equals to 6 hours. But remember that in order for us to have to calculate the distance, right? In order for us to calculate the distance, we would have to actually do this. So remember that the distance is represented by this formula here, right? ST distance. So how do I get this to that, right? So this is S prime T, right? And then it's negative 3T squared. Remember, this was derived up until this point. So if I say my derivative is negative 3T squared, then plus 18T, how do I get this to ST, the original formula? Now I have to understand that this becoming negative 3T squared means that initially here I only just had a negative, right? And then this is what I do. So note how I take it back. Remember, I know that it's a jump down and then subtract 1. If I bring back the 1 here, this is supposed to be negative 3. This is supposed to be negative T and then cube, right? Now I'm going to use this cube here, this 3, to divide to that negative 3, which will give me negative 1. So this is supposed to be negative T cube. And then again here, I know the same thing happened. Exponent jump down and multiply with the coefficient. So if this is 18T, I know that it actually comes from T squared. And then there has to be a certain number that multiplied with the 2 so that we can get 18. So I'm going to take this 2 here, divide it to this 18. So 18 divided by 2 will give me that the number in question has to be 9. So that's how I find the original equation. So my original equation for the distance is what? ST is equals to negative T cube plus 9T squared. But then remember that the time is 6 hours. So we want to find what is the distance that has been covered in 6 hours. So in 6 hours, we would have to say if our T is 6 here, then what is the distance that has been covered within that 6 hours? Then we put the 6 there, put it into our calculator. Then we find that it will be 108 kilometers, right? So it's 108 kilometers. That's the distance that has been covered. So that's how you are supposed to get that. But then you have to actually get it from all of this, understanding that your ST is the distance, your S prime T is the speed, and then your second derivative in terms of T is your acceleration. So, right. Pretty interesting question there.